All right, here's a question about people picking and replacing cards. We're going to do part A here. What are the odds against at least two people choosing the same card? Now, when we see the word at least, it's probably best to first figure out the opposite of what they're saying. So I want to figure out first, what's the probability of no two people choosing the same card? Okay, so in order to do that, let's think about the first person, right? The first person can pick any card that they want, right? So really, it could be 52 out of 52. It could be any card. But then the second person just can't pick the card that the first person got. So really, that person can only choose 51 out of 52 cards. And then the third person can pick any of the two cards that the first two people picked, right? So that's why they're at 50 cards. Okay, and then we just keep doing that. So that's 49 out of 52 and 48 out of 52. If you want, you can write the numerator as a permutation, as 52p 40 of 5. My bad here. Let's undo. Can I undo? Can I undo? No, I can't undo. Erase. There we go. 52p5 over, and then the denominator you see is just 52, and that's to the power of 5. All right. You crunch the numbers, you're going to get 0.8203. Now, we want the probability, though, of at least two people choosing the same card. So really the probability of at least two people is just the complement of no two people. So it's 1 minus 0.8203. And that's 0.1797. All right, and now we're talking about odds against. So odds against is P of A prime to P of A. So let's look at the odds against at least two people. So the first number that we want to write is the opposite of at least two people, which is no two people. So the probability of that is 0.8203 to 0.1797. All right. So again, when we see at least two, we really just want to find out the opposite or the complement of that. Let's look at part B. So here, what are the odds against at least two people choosing the same denomination? So again, I see the word at least. So it's easier to find the complement of that. So we want to find the probability of, of no two people choosing the same denomination. So the first person can pick any card. Okay. The second person, however, can't choose the same denomination. So denomination meaning like aces or kings or twos or fives or whatever. So it can't choose the same denomination as the person before it. So that eliminates 4 cards. So that's why the next person can only choose 48 possible cards. The next person can't choose any of the denominations of the first two, so they're down 8 different cards. So now we're down to 44 out of 52. And you see the pattern here, 40 out of 52, and then 36 out of 52. We crunch the numbers there, so you multiply the numerators, you divide it by the product of the denominators there, you're going to get 0.4160. So the the probability of at least two people choosing the same denomination is just a complement, so it's 1 minus 0.4160, and that'll be 0.5840. And now again, it's talking about the odds against. So odds against are, you write as the probability of A prime to the probability of A happening. Now, it's saying at least 2 people choosing the same denomination. So that means I'm going to write down the complement of that. So no 2 people is the A prime, the probability. So 0.4160 to 0.5840. Okay, tough questions, but again, the main idea here is that when you see at least 2 people, it's easiest to find the complement of that first. Okay, all right, thanks for watching.